Hello, I'm going to show you briefly how to make an IP from the RTL design files that we already have. Okay, before moving forward, I already made a directory with your name Ariane, and I copied in the original file all the RTL files that you already gave me. Okay, so we're gonna focus on that one. First, we go inside this file. It's README. When we double click, let's see what it says. Here it says the vMode RTL module includes the vMode NVDLA Verilog implementation of NVDLA. Okay, this folder, this directory is the only thing that we need so far in order to move forward with our IP integration. Okay, so we just minimize that one, and we know that inside this vMode NVDLA, everything that you see here are the Verilog files that are associated with the design. But one of the mistakes that you already have been doing is that you were trying to import all Verilog files from the top file down to everything else in a single design. And that's why your design was corrupted and was not able to create an IP for you. Now I'm going to show you by referring to two theses that you already shared with me. I'm going to show you how it works. Okay, good. Let me just keep my cursor here in this directory, and I'm going to show you in this first project. This is one of the theses that you already shared with me. And here I come back to this point. Okay, look, when we go to the page 29, it says that NVDLA underscore 0, which is the name of the file, IP, whatever you want to call it. Okay, this is the IP integrated IP1 that has the DLA core clock, DLA CSP clock, and whatever. And on the other side, we only have one AXI master port. But when you come further down, you see a very interesting and surprising thing. There are two more IPs that we already have to integrate prior to proceeding to integrate the larger one. Look at the name NVDLA. Look, NVDLA APB2CSB V1. If you look at in the folder that I already showed you, that I already have a copy of your original files here, it says APB2CSB. Look, here is the file we have. Okay, I'm gonna show it to you. Look, NVDLA APB2CSB V1 V version 1 underscore 0. This is the name of the IP which is associated automatically after the IP is generated. You are free to even delete the version number or give it another name as you wish. But the more important thing is that, look at the pins here. P clock is here. P reset N, P reset N. CSB to NVDLA ready, we have this signal. NVDLA to CSB data, it's 32 bits, we already have it. Okay. We already have that one. And the valid signal, we already have that one. Okay. Some of the other signals are already hidden. P address, P enable, P select, PW data, P write, CSP to NVDLA address, no response valid, W data, write. Okay, CSP to NVDLA write, it's here. This data, W dat is also here. PR data is hidden, P ready is hidden, no respond is here. address is here. So some of them are, these are the outputs, these are the inputs, and these are the hidden in between the modules. These are mostly used for internal connections between inside this module, which is hidden from our site right now. Okay, and now we see, look, p clock input, p reset n is input, p select input, but look at this comment, APB interface. It means that this is internal. If we go back, go up, you see I already told you some of the signals and pins appear to be hidden. Okay, this one is hidden because it is connected to an internal signal in order for internal routing. So it's not required to be a direct input or a direct output here. PW write, P address, PW data, PR data, P ready. The same for the output files. Some of the outputs are, for example, CSP to NVDLA valid. This is the data. The ready signal is hidden, and the address is there. The W data is 32 bits is there. The write signal is there. The no respond signal is there. And these are the two signals that we already have. NVDLA to CSP valid, NVDLA to CSP valid, and NVDLA to CSP data, NVDLA to CSP data. Input NVDLA CSP complete. It seems that the instantiation of all the input and outputs is now complete. So look, this module, this code defines this whole IP altogether. First, the first step is to create this module together. So how? We're gonna create a Vivado. Vivado. My computer is running slow today. Okay, it's because of the live streaming and recording. Okay, prior to moving forward, look at this directory. I came back to Ariane subdirectory folder. Okay, here are original files. Do not, never, ever make any design inside the file directory that you have the original files, because it's gonna corrupt your original files, and it's not possible, or it might be very difficult to retrieve them. So if you hear me, go back to one step behind and create a new folder like project. For example, you see NVDA IP trial 1. This is the one that I did with myself, and I'm gonna do a second trial with you in order to learn how does it work. So let me just squeeze that one a little bit in order for you to be able to follow that. Okay, we go here. You see a circle around my cursor. Wherever I click, it shows you a circle which shows the path that I go. Create a project. Again, because of the live recording, my computer is running a little bit slow. We go to next, look at this directory. You can copy this path and you can paste it here. It was already here, but I wanted to show you where is the path that we have here. Okay, project. And now I can give you the name. In order to be consistent with the one that I already made for you, I would say NVDLA hyphen IP hyphen trial 2. Okay. You want to choose an RTL project. Look. And we want to add new files. You go back, you go to the original files, you go to the hardware small, whatever name it has. You are allowed to import your files from here, but never create any Vivado project inside these files. It's gonna corrupt your entire codes. Go to vmode because we already learned from the this README file that the vmode directory includes the RTL modules, that the vmode NVDLA includes the Verilog implementation of NVDLA. Look, we are inside vmode. It tells us to go inside NVDLA. Okay, do you remember that I told you here is the NVDLA APB to CSP? Something interesting. This is appeared in the first thesis that you already shared with me. You might have asked, might have this question that is it exactly the same that is happening, that is repeating inside the second thesis, which is for the Politecnico Torino? Yes, look here. Voila. This is the NVDLA 0, which is the wrapped and integrated file altogether. And look at this. Again, it is the NVDLA APB to CSB 0. What is the difference between this one and that one? If you ask me, both of them are the same. Okay, there is no difference between this one, between this module and this module. But for some reason that I'm going to tell you now, I like this module more than the others. Why? Look at this pin, APB underscore S, which denotes the slave, okay? If you look at that one, you're not gonna, as you're gonna see later in the IP creation, you're gonna get confused. What are the pins associated? What are the signals and pins associated to this bus? Because this is a bus. You see, look at the shape. Look at the shape of them, but it is not the similar, this one similar to this, similar to this. It's a bus bar, you know. You're going to have this question going in your mind. Okay, what is the signals associated with this bus? And if you cannot identify them properly, you're going to get a problem. Your IP will not work properly. So, but I like the idea that this guy has been used here. You know, he has opened, you see, when it has a plus, it means that it's closed. When it has a minus, it means that the guy has clicked on it and it shows all the associated signals to that. Okay, we're gonna learn that once we're gonna associate the ports. We have to choose these signals to the same bus APBS. Great. We go here and I hope you did not forget that one. Okay, we came here, I repeat that one. We're gonna go NVDLA IP trial number 2, which is in the Ariane projects, okay? RTL project. We go in the add file, we go one step up, we go to original files, we go to small, we go to vmode. According to this, we learned that we have to go to vmode NVDLA. We go to vmode NVDLA. We go to APB to CSB. This is the module that we learn. We have to integrate it first. We go to that one. We click this. We click next. We click next. We go to board. We go here. ZCU 102. We do click here. If you click here, it's gonna open the user manual for that, okay? Then you click here, then you click finish. Okay, now we see our associated board and it's updating right now. You see NVDLA APB to CSP. It's a Verilog code that is now inserted here. So now we're gonna learn how to convert this Verilog code, which appears with the .v extension, into an IP. We go to Tools, Create and Package New IP. Click Next. If you say package your current project, you have three options: package your current project, package a specific directory, create a new AXI peripheral. So most of the times we are confused which of these three options are suitable for us to choose. It depends on which state of the project we are. I repeat myself, it depends on which step of the project we are. Look, if you are at a stage, let me go back to this one, which I already said I like this module better than the others. Okay, if you are here at this stage that you want to integrate the IP for the bigger top module, you see there is no AXI input for this signal. Okay, and for the other one, oh, sorry, here, there is one AXI master at the output of the NVDLA, and there is one AXI input, one AXI output. So if I go here, if I click this one, there's not gonna be any AXI input. Look, we need this AXI input for this module. If you look at that, it requires an AXI input. This is an AXI input, and this is the wrapped model. Look, this pin is an AXI. This pin is an AXI. What happens if you integrate an IP without an AXI input master or slave? It's not gonna be connectable to any other uh, modules inside your block design. So we move forward and we choose the third one, create new IP peripheral. Okay, I call it NV. Let's give it the name that is exactly appears in the module. It says NVDLA which is NVDLA, NVDLA, APB to CSB, APB to CSB, That's it. This is the version number one. This is the one that I already told you it's gonna be associated automatically. Look at here. It's gonna be associated automatically by the IP integrator. So override existing, there is no need to click that one, because if you look at here, I created a fresh directory, a fresh project named IP trial 2. But if you already have worked on it, you better override existing. However, I do not recommend of overriding IPs on top of each other multiple times. For each trial, you better create a new trial, which is not a big deal, because if something happens later to one of them, you still have the chance to get back to the previous versions and retrieve whatever you have missed. But if you override them on top of each other, you won't be able to get them back. So there's no need to check this one, leave it unchecked. Look at the IP location. IP location is gonna be, I write it from here, which is important for you, from Ariane projects, IP trial 2, IP repository. Next, look at this. It says the IP that I'm gonna give you, it has this shape. Okay, this is so far, this is good. Let me double check with my own design. I need something that has an AXI input and a couple of other inputs and outputs, which so far it only provides me one AXI input, which is good, but there is no other input and output. So you have the choice to leave it light, full, stream. A stream is for the, for example, video streaming, which is out of the scope of, or the Ethernet uh, serial signals, which is out of the scope of our project. You have the chance to choose either the light or the full, but I would recommend to choose the full, that we still have, if we see that the full is too much for us, we still have the chance to revert it back to the light later. So we choose the full, we click next. Okay, add IP to the repository. What is the next step? Add IP to the repository, edit IP, verify peripheral IP using JTAG. Okay, we're gonna say edit IP because why? Because look at the interface. This is not the same as the one that we are looking for. No, this is so much different than this one. So we're gonna move forward and click the edit IP, finish. Something interesting is happening right now. If you look, a new wizard has been just opened. You see that one? A new window, a new design project has been opened on top of the other one, which the previous one is considered as the master and is now, this one is like a slave. Do not mix it with the master slave concept in the block design. I mean, this is the primary and this is the secondary. Let's name it in this way. If you go here, you see all the check marks are good. Identification, compatibility, file group. This is the customized parameters, ports, and interface. What are the ports? This is the ports here. And customized GUI. Okay, this is good, but is it exactly the same thing that we want? No. None of the ports are similar or identical to the one that I'm looking for. So I put it here. You compare this one with that one. So what should I do? I repeat myself. Remember, a second window, you see here, a second window has been opened on top of the first one. Never, never, ever. Do not touch the first one. Always look at the second one where you have this IP located. You see this IP, okay? On the other window, you don't see any IP. So I just put it up on top of the other, not to mix it with the other one. In the window that you see this IP, double click on this file. Here is the Verilog code that has been automatically generated by Vivado when you have created this IP block, okay? Now, What should we do? Now we go back to, so we are in this Verilog code, which we don't like it. We go to the IP repository that we already have your original files, HW is small. We go to vmode, we go to NVDLA, we go to APB to CSP. Look, this one, right click, open. This one. If you look at that, here is the code for that module. The code for this block that is shown inside this PDF, this block has this Verilog code. So you do a copy, you come here. Remember, you should still be in the same page that you see this IP. You come here, Control A, delete, paste. You delete the previous Verilog file, which was already generated for that one, and you paste this and you do a save. Once you do a save, you come back to this window and you see something is changing. It says automatically pick new top module. Yes. And look at here. It says merge changes from customization GUI wizard. It seems that your code right now that you have just posted here is not compatible anymore with the shape of the IP that we have here. So we do one click here. We ignore this error because we have not yet done with the modules. Okay, something interesting is happening right now. We have some sort of the data. Okay. Some sort of the good information here. I'm just gonna put it side by side just to show you what is the difference between this one and the other one. Actually, I'm looking for this one. Computer is running a little bit slow because of the video recording, and I have to bear with it. Okay, now I could put them side by side. Look, something interesting. So far, we have created this module while we are supposed to have this one. So it has one AXI input, one AXI input. No matter what is the name, we can change the name. It's not a big deal. P address. These are the inside this module. Sorry. Let's go P clock, P clock. P clock here, we have P clock. P reset N, but which is negative, which is the active low. Ours is active high. I'm gonna show you how to change it. This is not a big deal. CSP to NVDLA ready, CSP to NVDLA ready. NVDLA to CSP data, NVDLA to CSP data. NVDLA to CSP valid, NVDLA to CSP valid. Okay, and the other signals, look, P address 31, 32 bits, 31 to 20 should be integrated here. P select should be here. P enable should be here. P write should be integrated into this AXI. And PW data 32 bits, PW data 32 bits should also be integrated. 2467. 2467. Okay. And on the other side, we have CSP to NVDLA address, CSP to NVDLA address 16 bits, CSP to NVDLA no respond, we have it. CSP to NVDLA valid, we have it. CSP to NVDLA W data 32 bits, and CSP to NVDLA W data 32 bits, we have it. CSP to NVDLA write, CSP to NVDLA write, and this pin is supposed to be hidden, and PR data, no, it's not hidden, sorry. PR data is supposed to be here. Look at the direction. It's the output, and P ready, which is the output here, should be here. It is also an output signal. The other signals which you see, this arrow, this rectangle is toward the right. It means that they are input, but these two signals are coming from the output side. It's coming from here and here, which are the outputs, should be integrated inside this axi. So interesting. Now we move forward with the component name. It says that, okay, component name, it's not correct. Let's go to the ports and interfaces. To the ports and interfaces, the first thing that we're gonna do is to change the name of this axi S00 axi, slave 00 axi to APBS. Double. We do here. I'm trying to, okay. You have to double click here. Here you see, you do APBS. We double check with the design. APBS, slave, which is at the left. And its presence should be mandatory. We do okay. At this time, if you go back to the customization GUI, you're gonna see that the shape has been changed to APBS. Okay. And now it says that in the category of the APBS, there are multiple multiple signals that has to be associated with that one. So we keep this one here and we try to push that one a little bit there. I'm just trying to keep both files together. This file I'm looking for. Okay, I'm just trying to figure out something. Word mapping. Interface definition, auto interface bit. Okay, it says P address. Let me see. I'm just trying to see. I never tried it myself before creating this video. So I'm just trying to PW data, 32 bits, P ready, APR data 2467, 2467. Okay. Right click. I have chosen all of them. Add bus interface. Create interface definition. Auto infer interface. Okay. Auto infer interface. In signals. IO interface. No, this is the much advanced stuff. User. Add bus interface. Associate clock. Edit interface. Import IP ports. No. Auto infer. Already. RID, RData. No. Import IP port. Add bus interface. Bus interface. We name it APBS. Display APBS. Port mapping. APB. No. Port map. Okay, Ariane. I have to figure out more about this item. So far have this kind of the video and try to do it yourself and try to continue it on your own too. Try to integrate all these 7 pins that you see here, 7 signals into the apb.s. So please feel free to take the snapshots of the video whenever you want and show it in your tomorrow's presentation while we have a meeting with Claude. Good luck and let me know when you as you progress and achieve something new. Bye.